Hello dear students, I am Dr. Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. In this lecture series of this solid waste subject, today I'll discuss about the processing of solid waste. Means processing before it is going before to the MRF site in at the final recovery station. Before what processing we should do and how this whole process will be started. So this is the whole picture related with this municipal solid waste management. So this in this municipal solid waste management, we have discussed from this waste generation to primary collection, then secondary collection, and after secondary collection, the place coming, the phase is the processing and transformation. Processing of solid waste, processing of solid waste to either to receive waste from energy from waste, either to receive energy from waste, energy from. So in this for the processing of solid waste, we are doing to get energy from waste, and for either to resource recovery or to follow the principle of R3, that is reduce, recycle and reuse. So to get all these things, to achieve all these things, processing part is there. Processing will involve the what method should be followed before entering it into the MRF location site, or to before entering it into the MRF, material recovery facility. For which type of waste is there and which methods are we followed for this type of waste. So first of all, we'll discuss about this thing. What is this MRF facility? What is this MRF location? So MRF means material recovery facility, or material reclamation facility, or material recycling facility. Means three words are there: recovery, and either reclamation, or next is the recycling. Means recycling, either it will related with the material recovery, means recovery from that material, recovery of something, some resource, or either reclamation, like reclamation of the solid waste, and then recycling phase. So all words will denote a single meaning, that will be getting something from the waste. If we'll talk in a general, like what this MRF location site is doing, it is like utilization of waste, and to get some important resource from these materials is called, that way this MRF sites are there. So it is a place where waste collected from the doorstep in a segregated manner is further segregated, and various component of recyclable waste recovered from it for recycle or resale. So this is the actual meaning of this MRF site. MRF site will be MRF site will be there. It will denoted three words, that is recovery, reclamation and recycling. So it is a place where waste is collected. MRF is a place where the solid waste is collected from the doorstep in a segregated manner, in a differentiated manner, like from a curbside. Either which type of waste collection method is there, it is from either from curbside or from waste collection method. So waste has been collected at the doorstep in a segregated manner, and then it will be further segregated. First segregation, and then next again one step is there, that is segregation. And after that segregation, it will be divided into various components, and from that components, recyclable waste should be recovered from the for recycle or resale. So this is the actual meaning of this MRF site. And it is an specialized plant. It is a kind of plant that receives, separate and prepares recyclable material for marketing to end user manufacturer. So this is about the MRF site. What does it mean, and what function it is following? So it is a place where waste is collected from the doorstep in a segregated manner, and is then further segregated into various components of recyclable waste that is recovered from recycle or resale. And we can also say that it is a specialized plant that receives, separate and prepare recyclable material for marketing or end user manufacturer. So this is about this MRF site. And now we'll discuss what process will follow. What is the principle behind this material recovery facility? So first step is like mixed solid waste is separated based on their source of recovery of material. So mixed solid waste are separated. First we'll separate the solid waste, like segregation part is there. segregation part is there. Segregation means separation of waste or distribution of waste. Distribution or segregation of waste. Segregation of waste based on their source of recovery of material. Next is the process, or the depends on the degree of source separation of waste. Next is the process is there, and that process depends upon the degree of source of separation of waste, and the nature and design of each unit operation accommodate the physical characteristic of the source material. Obviously it will related with the physical characteristics of the waste, then only we can identify the waste, and it will going through the whole process. So the nature and design of each unit operation accommodate the physical and chemical characteristics of the solid waste. Next step is the resource recovery, and the resource recovery will play an important role in the economies of the developing nation. Obviously resource recovery is the final step, and this resource recovery is very much important because it will be helps economy of the developing nation, and it is very much beneficial for economy and for a normal person, because we'll get fuel from this waste. That's why these MRF sites are very much important. So we'll discuss how the actual, this is the picture of the actual material recovery facility site. This picture will denote, like, see, here a truck is there. This truck is there. From this truck, waste, paper, glass, plastic, whatever it is there. So through a ramp is there. From this ramp, the waste is going into here. Here, what is the function is following? It is air sorter. Air sorter is there, and they are sorting the waste, like segregating. Secondary selection is there. Secondary segregation is there. Segregation of waste is there. Then with this is the air sorter, and then metals and cans are at different place. They have sorted heavy metals at different place, and paper, glass remains are at different place. Iron here also, and then stone on some bottles are at one place, and then it will goes through the either with the, if stone bottles are there, then from via this ramp it will goes through a hammer mill, and then to via this ramp it will go through air, blow and dry, and then next is the material recovery facility. Whatever the method should be there for that particular waste will be there. So this is the whole picturization of the material recovering facility. It is available into all municipality, and this is a very advanced form, and in foreign it has been established everywhere, and from this way, by this mechanized way only, the sorting should be there. You can see many videos on the YouTube that is related with this material recovery facility. You can see the video of Indore community, Indore municipality, how they are doing this material recovery facility efficiently. You can see the I'll share the link, in which link you can see the Indore municipality's material recovery facility. They are bringing from up to here. This is manual only, and labors are there. They are bringing up to truck, and from truck all are like mechanized one. There is a sorting of all waste, like metals at one place, heavy metal, heavy plastic, papers, plastic, glass remains is at one place, then iron one place, then stone bottles, sieve, and then cork, paper, plastic, whatever is there, they are segregating the waste, and in a very mechanized way, and so that the person will not dispose to this type of waste. And this will be followed only for the dry waste. One point is there, this will be followed only for the dry waste. Obviously organic waste is not involved in this material recovery facility. Organic waste is not at all involved in this material recovery facility. So this is the actual picturization of this material recovery facility. Now comes to the next point. This is what type of process is involved in the MRF techniques. Process involved in the MRF techniques is the first is the manual method, and then mechanical method. Manually, it should be done at a very at a small scale. At a small scale, this type of manual should be done, and then mechanical method is there. In the mechanical method, three type of method are there: electromagnetic separation, fluid dynamics, and pneumatic. These three types of first is the electromagnetic waves are there, then fluid dynamics is also used, then pneumatic system is also used, and other processes are there, that is a reduction in size or air classification or screening only. So this mechanical method is like a very technical method, and first one is they are using electromagnetic waves to separate the waste, then fluid dynamics also, and then pneumatic system also. In this pneumatic system, with a high pressure, the waste will be moved from one place to another place. Mechanically, manually, it should be done on the very small scale, or very less, if less waste is there. But mechanical method will be followed when more waste is there, more waste and on a large scale, more waste and on a large scale. So this is like, and some other processes there, which is like size reduction, then classification through air, then screening of the waste. Now we'll discuss everything on the in details. So for mechanical separation, which is the most important point for mechanical separation, there will be a size reduction of the waste, then glass separation is there, air classification, non-ferrous separation, and screening, densification, magnetic separation. So for mechanical one, these things are be followed. First is this reduction of size reduction in the size, that comes under size reduction in the size of particles, so that like shredding and everything. Then separation of glass particles, then air classification by the high air is used to classify the waste. Air is used to classify or segregate the waste, Then next is a non-ferrous separation is there, then screening of waste, and then densification, density will be there, then magnetic separation by the use of some magnetic devices. So these are the different mechanical separation methods that has been used in these MRF sites. Next point is like the what is this manual processing? Manually, what is doing? So first, for manually, bulky items are there, like some appliances, like some furniture are there, or specified contaminants, like we know that this is the contaminant. Some big item are there, like some discarded furniture, some discarded clothes, some discarded appliances. So it can be done by manually only, because manually a person can use it. Then manual separation is applicable to the removal of contaminants from source separated material. Equipments involved in manual separation of materials usually includes a sorting belt or table, which contains a mixture of materials. So the equipments that has been involved in the manual separation of material will usually they include a sorting belt. Obviously some sorting belt is there, or some table is there, or some ramp is there, which contains the mixture of the material. So these are the most of the what equipments has been used in this manual processing. So either it is a belt or a table, or sometimes a ramp is also there. So this will be the equipments that has been basically used in manual processing. Hopper and other receptacles for receiving removed item are positioned within each of the sorters. Some hopper are there, some receptacles are there for receiving removed item, and are positioned within each easy reach of the sorter. So these are the discussion about the manual processing, how this manual processing of waste is done. Next is the this type of waste is there. This is the example of the some of the manual processing. In a manual processing, what we can separate. First is the newspaper. It is like 700 to 4500 kg per hour a person can do. Same thing for the corrugated materials also. Glass containers are there, some mixed color are there. It is to 400 to 800 kg per hour per person. Glass containers, if we categorize by color, then 200 to 400 kg per hour per person. Next is the plastic container. Plastic container like PET or HDPE, it is 140 to 280 kg per hour per person. Next is the aluminum can also. This can be done by the manual segregation. Manual segregation is followed for these type of methods, because these are the big one only, and these can be done by a person. That's why these are the examples that we can use for the manual processing of the waste. Next is the size reduction. how this size reduction is done in during this MRF site. So first, a process of mechanical reduction of size of collected material to obtain a uniform final product. Process of mechanical reduction of size of collected materials to obtain a uniform final product and reduce storage and shipping cost. It will benefited in the terms that it is going to reduces the storage and shipping cost. It is not a volume reduction process like shredder paper occupy more space than the parent stock. So it is a that kind of material. This shredder or some hammer mill is used for this size reduction. Hammer mill is like that. It is a reduction of size of collected material, means due to this hammer some shaft is there, so by putting the hammer the size of the waste has been reduced. It is not like a shredder paper, like, because if shredder is there, shredder will occupy more space than the original waste. So this hammer mill is used for this process, for this size reduction. And in this size reduction hammer mills, you can see that one feed is there. By this feed we can put the waste, and the shaft is there, shaft and hammer is there. With this shaft and hammer, they are pressurizing, they are putting the pressure on this waste, and this is going to be very much reduced the size of the waste. So this will be like reduction, size reduction. For the size reduction, this hammer mill is used. Many devices are there, but this is a very common device, that is hammer mill, where one feed is there, then shaft is there, rotor is there, and hammer is there. So with these all the things, the size of the waste collected is it will be reduced, and this is a mechanical reduction of size of collected material to obtain a uniform final product, and it helps in the reducing the storage capacity and shipping cost also. It is like not a volume reduction process like a shredder paper occupy more space than the parent stock. Now comes to the next method, that is screening. Screening is also there in this MRF site, MRF location. So screening is like a process of separation of mixture of material of different sizes into two or more size fraction by means of a screen surface. So the process of separation of mixture of material of different sizes into two or more size fraction by means of a screen fraction. Obviously, it is like a separation of mixtures of material, and it is of the size into two or more size fraction. So the main objective of this is, screening is like it is going to remove of oversized and undersized material and separation into light and heavy material. Light is like some combustible paper, this is the light one, and heavy is like some non-combustible glass fraction. So this is separation of this screening should be used for the separation of light and heavy glass fraction. So removal of oversized and undersized material is like some vibrating screen is there. With this screen, some rotating screen is there. So it is a process of separation of mixture of materials of different sizes into two or more size fraction by means of a screen surface only. So the removal and its main objective is to what to do is like it will remove the oversized and undersized material also. Separation into light combustible paper and heavy non-combustible glass fraction. So this is a picture. You can see that feed is there. With this feed, larger particle will enters and it will be separated. A small particle will be separated like this and into with this screen, and the two large particle will come out from this feed screen is there. So this is the actual picturization of this screening process that has been installed in a MRF site, and this is the vibrating screen. With this vibration, the smaller particle will be collected and larger particle will be separated. So this screening is like a separation of mixture of materials, and it is used for the separation of waste, separation of waste, and it is like a removal of oversized and undersized material. Obviously, it is oversized if some impurities will be there, or if some oversized material are there, if some undersized material are there, and then separation into light like combustible paper and heavy non-combustible glass fraction. Now comes to the next point. This is like density separation. For the density separation is like air classification. Air has been involved in the whole process. So a process of separation of light materials such as paper and plastic from heavy materials such as metal based on weight difference in the air stream. It is like separation of light material from like a paper and plastic from any heavy materials like such as metal based on weight difference in the air stream. So in solid fraction, the light fraction is typically organic while the heavy fraction is typically inorganic. It is used to separate plastic from commingled situation. So you can see that this is the actual picturization. Means it is like a separation of light material, like if some light material will be there like some paper or some plastic, it should be separated by this air classification method, and the heavy material like some metal based on the weight difference in the air stream. So in solid fraction, the light fraction is typically organic while the heavy fraction is typically inorganic. It is used to separate plastic. Basically it is used to separate the plastic. So this is the picture is there, you can see this is the whole picture, and this is the working principle, how it will work. So is a heavy fraction is there inside this, then air stream is there with the air with very high air, some rotatory air lock. It will by the light it will blow through the blower, and exhaust air is there. This is cyclone separator, this will separate, and the light fraction will be separated here. Light fraction will be separated here, and in the cyclone separator it will be automatically collect inside the cyclone separator with very high air with a density separation. With the density it will be separated from its higher fraction into the light fraction. So the light fraction and higher fraction will be separated, and this is basically used to separate plastic from a commingled situation from a mixed. If many mixed waste are there and if we want to separate only plastic, then this air density separator should be used. It will separate the plastic from the mixed waste. So this is like this is basically used for the lightweight material like some paper or some plastic from heavy materials, or like some metal based weight difference in the air stream. So it will be basically works on the weight difference of the waste. So if it is lighter in weight, then it will be flow high. So it will be flow high, so it will be separated through the cyclone separator. It will be separated, and we can collect from here only. This is the actual picture of this air density separator. Next is the magnetic separation. In the magnetic separation is magnets is used, and it is basically used which separate ferrous metals from the metal waste utilizing magnetic principle. With utilizing magnetic principle, the ferrous metals from the waste stream has been separated, and separate tin cans from aluminium in a commingled situation. Commingled is like mixed waste is there. If mixed waste is there, so this magnetic separation is used to separate the ferrous metals from the waste stream. Means many mixed waste is there, commingled waste is there. So from that on only ferrous metals should be separated by using some magnetic belt. Over magnetic belt is there. So you can see the picture. This is magnetic separator. This is a whole picture of magnetic separator. And in this picture you can see that there is a belt of magnetic separator is there, which will collect the ferrous metals from the mixed waste. So this magnetic separation is also used in this MRF site. Now densification. Densification is like compaction of the waste. Densification is a process which is used to increase the density of any material so that it can be stored and transported more cheaply as a means of preparing densified refuse derived fuel. Obviously DRDR. So what is this? It is densified refuse derived fuel, and it includes balers and can crusher. You can see the picture. It is a process. In this process, it will increase the density of any material so that it can be stored and transported more cheaply. It will increase the density of any material so that it is very easy to store that material and transported more cheaply as a means of preparing. It will be transported very easily as a means of preparing this densified refuse derived fuel, DRDR. For this refuse derived fuel, this densification is there, and it will be like compaction of waste. And during this process, it will increase. It is going to increase the density of any material so that it can be stored and transported more cheaply as a means of preparing densified refuse derived cell. It includes balers and a can crusher. The equipments used in this densification process is the balers and the crusher. You can see this is a picture of a baler. Now next is the air classification. Air classification is again it is like a process of separating categories of material by way of difference in their respective aerodynamic characteristics. Aerodynamic characteristics, and the aerodynamic characteristics of a particular material is primarily a function of size. It is like it will be related with the size, geometry and density. Basically it will related with the size, geometry and density of waste, and the suspended fraction conventionally is referred to as a air classified light fraction. Obviously if its density will be less, then it can be denoted as like of air classified light fraction, and the settled fraction is termed as air classified heavy fraction. So on the basis of size, geometry and density, it will be separated. So those which will be separated is called as air classified light fraction, and the which will be not separated, or they are the settled fraction. They are those which is having a very high density, automatically it will be settled bottom of the tank. So this settled fraction is called as air classified heavy fraction. The confined volume in which separation takes place is called as air classifier. So the volume in which the separation takes place means the volume in which the separation is there means light or heavy. So this is called as air classifier. This is called as air classifier. Air classifier will do like this. It is a separating categories of material by way of differences in their respective aerodynamic characteristics, and the aerodynamic characteristics of a particular material is like related with the size, geometry and density. And the suspended fraction conventionally referred to as air classified light fraction, and the settled fraction is called as air classified heavy fraction. So this is all about the air classification. You can see the picture. This is the explanation of this air classification. So first one is the horizontal air classification. Horizontally air is coming, and this is classifying light fraction here and heavy fraction here. Like this is a vibrating inclined air classifier. Some vibrating thing is there. This will go with the vibration. They are classifying the light particles and heavy fraction. Like this inclined air classification, inclined way, it can work for the inclined way also. And here also you can see that this is the air is coming, and this is the light fraction, this is the heavy fraction. And this is the vertical air classifier. This is vertically it is working, and this is by vertically, and this is like a mixed waste is there. This is coming from this side, and light fraction will be separated here and the heavy fraction will be separated here. So this is air classification is mostly followed in these MRF sites, because if a mixed waste is there, to classify the waste on the basis of its density, this heavy air should be there on, and if air will come, then it will be separated in two categories, that is light density and high density. Light density and more density. More density will be settled inside the chamber, and light density will flow into another chamber. So this air classification is mostly adopted in this for the plastic waste. Basically it will be used for the plastic waste. Next you will come to here, this aluminum glass separation. How this aluminum and glass separation is there? So the predominant non-ferrous metals represented in the waste stream is usually aluminum, and it is oftentimes a target for this recovery. In the case of aluminum, heavy media and ED current separation are possible. ED current should be there. ED current will apply to separate aluminum. And ED current is like at present more commercially feasible. It is very much feasible. Separation is brought about by ejection of aluminum particles from a moving waste stream due to the force exerted on the metallic particle as they pass through an electromagnetic flux generated by the equipment. Separation is like it will be ejection of aluminum particles from a moving waste stream due to force exerted on the metallic particles as they pass through an electromagnetic flux generated by the equipment. So this is like aluminum and glass separation. The predominant non-ferrous metal represented in the waste stream is usually aluminum, and it is oftentimes a target for its recovery. In case of aluminum, some eddy current separation are used, and this eddy current separation is at present the most commercially feasible. Separation is brought about by the ejection of aluminum particles from a moving waste stream due to the force exerted on the metallic particle as they pass through an electromagnetic flux generated by the equipment. Now, the conclusion of this lecture is like the material recovering facility for the waste management system should work efficiently, and this MRF method provide recycling of raw material for industrial use. Obviously, this recycling is important for using it in the industry or for the economy of the country. So this after studying this processing of the waste, we are coming at the conclusion side, and with this conclusion we are making the conclusion like the material recovery facility for the waste management system should function efficiently, because its efficiency is more important. Efficiency and cost effective, these are the most important point that is related with this MRF site. And then next is this method provide recycling of raw material for industrial reuse for making RDF. RDF resource fuel is there. And next is it should follow the principle of R3: reduce, reuse, and recycle. Reduce, reuse, and recycle. So this is the important point that has been related with this processing of waste, and this processing has been adopted in MRF sites. And the first is it is like based on either it is based on the density, either it is based on its heavy particles, either it is based on the magnetic separation of aluminum cans or ferrous metals. So all mechanized instruments are there in the MRF's location sites, and these are the some of the references of some of the textbook which you can follow to get more deep knowledge about this processing of waste. And thank you for today's lecture. And today I'm going to I want to conclude this lecture at the point where this MRF location site is the very important, and the process we have discussed about the mechanical process that has been followed for the separation of mixed waste, like separation of plastic from the mixed waste, separation of aluminum cans from mixed waste, or separation of some ferrous aluminum, like this type of waste. And this MRF will work only for the dry waste and separation of plastic and everything, and plastic related products. And the process followed for this mechanical separation is air classification on the basis of its density, classification by using some electromagnetic force, classification by using some pneumatic system. So this is all about today's lecture. And if you have any query regarding this lecture, you can write in the comment box, or either you can mail me on the given mail ID, that is shikha.pandy@gmail.com. Thank you for today's lecture.
Like, share and subscribe. Hit the bell icon for more updates.